I'm going to talk to you today about the way that we think about climate change going forward. But before I do that, I want to just briefly tell you how I first encountered the issue of climate change, because it perhaps puts some things into perspective. As a college student, I took a course on the history of science. One of the subjects we talked about actually was how scientists first discovered that carbon dioxide could absorb infrared radiation from the sun. It wasn't a current discovery. It was actually John Tyndall, an English scientist, in 1860. His work was taken to the next level by a Swedish scientist, Svante Arrhenius, who published the first paper pointing out that the emissions of carbon dioxide could gradually increase the temperature of the Earth. He thought it would take hundreds of years because, of course, at that time, it was difficult to imagine how fast the world's economy would grow and how much we would come to depend upon fossil fuels, particularly coal, to generate electricity. So, in a way, it's an old problem that requires some new thinking. So, we've known for a long time that burning fossil fuels could lead to warming the Earth. What's new? The new feature is that countries have now accelerated emissions of greenhouse gases. We've already detected warming on the Earth, but what we're much more worried about is where this could be going in the future. And the reason we have to think about that now is very important. Carbon dioxide and several other greenhouse gases live in the atmosphere for a very long time. Unlike sulfur dioxide and particulates or the pollution we normally think about, these gases can stay in the air for centuries. One simple way to think about this is an analog often used to a bathtub. Imagine filling up a bathtub with a very clogged and slow drain pipe. The bathtub fills up faster and faster as the drain refuses to let the water out. And in fact, we are running the faucet at a faster and faster rate. Consequently, we're using up the capacity of the atmosphere with these greenhouse gases. So we know a lot about where we are today, but the real question will be, where are we going in the future? And in order to think about that, scientists use a technique referred to as emission scenarios. It refers to a pretty simple idea: to create a consistent story about what the future might look like. What we want to know is how much will emissions of carbon dioxide increase. And to tell that story, it's important to do it on a very detailed and consistent way so that all the climate models, which then use those scenarios to evaluate warming, can do so on a consistent basis. So while it sounds a little complicated, in fact, all these stories come down to just a few variables, fundamentally, a few equations, which are built upon assumptions about basically four things: population growth, more people, more energy use. Energy choices: will we be building more coal plants or more solar, wind, and renewable energy without releasing carbon dioxide? The third factor is economic growth. The faster economies grow, the more energy they'll need, and the more fossil fuels they're likely to consume. And the fourth factor is technological innovation. Some people think technological innovation will save us by, for example, allowing us to pull carbon dioxide from the air, or in a less dramatic way, removing through scrubbers carbon dioxide from power plants and pumping it under the earth. In any case, it's these four drivers that together constitute the basis for emission scenarios. So the next question is, among these scenarios, what stories are they telling us? Well, the first and perhaps most easily understood story is the one that says, where are we going today? We might be on a road with many choices to turn left or right, but let's start by simply assuming we're going to keep going straight in the direction we're headed today. Well, if that's the case, most of what we know is rather bad news. there appears to be a trend toward emissions that will take us well past the limit scientists currently think is a safe constraint, which is about 2 degrees centigrade global average. And in fact, it's currently projected that we're likely to exceed a 4-degree global average warming sometime between 2060 and 2080, unless some very dramatic changes are made. Now, while 2060 and 2080 sound like they're fairly remote, they might be relevant for our children and grandchildren, in fact, the time that we have to influence the future is much less than might be thought. So we have the problems of our current inertia, the challenge of introducing new technology, and the opportunity cost of all the energy efficiency we could be doing today that we will lose and not be able to regain in the future. The first, as I said already, these gases that we're emitting today are very long-lived. A lot of what we're doing today is largely irreversible. The second factor is that we're making a lot of long-lived investments that will be very difficult to change without incurring extraordinarily high costs. So you can imagine that a coal-burning power plant would normally be used for 50 or even up to 100 years. And if we instead discover that we have to substitute for those investments, we're going to incur a pretty high cost. Yet another is the importance of technological innovation and the fact that it takes a long time. So just to pick one example, if we want to install carbon capture and storage, we're still perfecting it. And it's not exactly clear when we'll have it proven, but let's say that it's in 2025. At that point, it will take, it's estimated, at least 2 decades to install enough carbon capture and storage to really be able to make a dent in the CO2 equation. The message I would like to leave you with would be, first, that we're living in a global bathtub and the atmosphere is being filled up with greenhouse gases. Secondly, that the emissions are increasing at a rapid rate and many new investments are on the horizon that would only exacerbate this trend unless something significant is done. And finally, the news isn't all bad because there still is time. There are many feasible options which are technologically proven, commercially available, and cost-effective if we do act in time.